Hi guys, welcome back to SQC tutorials, and you have engineer Almighty formula here right now. In today's video, I'm going to deal with past questions in pharmacy mathematics. So if you're in 100 level pharmacy, 200 level pharmacy, and you do trigonometry, this video was made for you. But then this video is not restricted to only pharmacy students. So if you're in any other faculty, you're an O-level student, you're still in your high school, whatever level you are doing trigonometry, this video is also for you. So we are going to use some questions, more than 3 questions, to explain how these formulas work. So before I solve all these questions, I'd like to introduce you to this formula. In my previous video, we did the basic formulas in trigonometry. This is the next set of formula you need in trigonometry. So the first one is when you have two angles added together and you want to find the sine of that sum. Now, what relationship does it have with the sine and cos of the individual angle? Now here we are having the sum, but here we are having the individual angles. So sine A plus B is the same as sine A first. Observe the way I arranged it. Sine A first before cos is sine cos, sine cos, sine cos. So you have sine A cos B, then you do the reverse, sine B cos A, sine A cos B, sine B cos A. That's the arrangement. So if you have plus here, you are going to have here plus. If you have negative here, you are going to have negative. But for cos is another ball game. If you have plus here, you have negative here. If you have negative here, you have positive here. But another difference is instead of sine cos, it is cos cos sine sine. So you have cos A cos B, change the sign, negative, sine A sine B. You have cos A cos B plus sine A sine B. Now I'll be doing another video on how we arrive at all this formula, how to derive all this formula yourself, but not on this video. I'll do a special video for it, and when I'm done, I'll drop the link under this video so you can also get to know how these formulas were derived. So for tan, the sign at the tan has both numerator and denominator. The sign at the numerator is the same, but the denominator is the reverse. So for sine, you have tan A plus tan B divided by 1. This one is always constant, 1 minus tan A tan B. So the numerator is such that it's either you're adding or you're subtracting, but the denominator, you are multiplying tan A and tan B. But what will change is the sign. So if you have plus here, you have plus here. If you have minus here, you also have minus here. But the reverse is the case for the denominator. You have plus minus minus plus, and you are multiplying. This one is constant. So you have 1 minus tan A tan B, 1 plus tan A tan B. And also observe it is always tan A before tan B. So with these formulas, we are going to solve these 3 questions, and we'll move over to other past questions. So the first question, given sine A 3/5, find tan 2A. So we are going to make use of our previous video, some things we learned there, and we'll also make use of these formulas here. Now if we are given sine A, how do we find tan A? Is important because we are looking for tan 2A. How do we find tan A? Remember in our previous video, we did an example that required us to square it. After squaring, we'll find cos and we'll find tan. Or we also said you can use triangle. You draw a triangle and imagine. So let me draw a triangle and imagine that this is A. What is sine? Sine is opposite over hypotenuse. So this will be opposite over hypotenuse. And Pythagoras theorem says that the hypotenuse square is opposite square plus adjacent square. So 5 square minus 3 square, that will be 25 minus 9, and that's 16. When you square root it, you get 4. So it means that this place is actually 4 units. So what will be tan A? If sine A is 3/5, what will be tan A? With respect to this guy, we'll have opposite, which is 3, all over adjacent, which is 4. So our tan A is 3/4. They can also ask you to look for cos A, whichever way. So the next thing is to look for tan 2A. Now we do not know what tan 2A is, but we know that 2A is A plus A. If I have one A and I add another A, altogether I'll have 2A. So tan, recall from all those formulas that tan A plus B is tan A plus tan B all over 1 minus tan A tan B. So instead of having A plus B, I will have A plus A. So tan A plus A will be equals to tan A plus, instead of tan B now, I'll be writing tan A again all over, I'll have 1 minus tan A. Instead of writing B, I'll write tan A again. So, and this will be tan 2A, A plus A is 2A. So tan A, you have one tan A plus another tan A. Altogether, you have 2 tan A. Then you have tan A times tan A, you have 1 minus tan square A. You have 1 minus tan square A. So now, do we know the value of tan A? We solved and got tan A as 3 over 4. We got our tan A as 3 over 4. So this is, instead of writing tan A, I'll write it as 3 over 4. Then we'll have 1 minus 3 over 4 squared. That will be 9 over 16. 2 cancel out here. We are left with 3 over 2 divided by 1 minus 9 over 16 is 16 minus 9. 16 minus 9 all over 16. So this is 3 over 2 divided by 16 minus 9, that's 7. 7 over 16. So if I change this division to multiplication, I will flip them. So if I change it to multiplication, the 16 will go up and the 7 will come down. So we have 16 over 7. 2 here, 8. 8 times 3 is 24. So we have 24 over 7. So it means that if sine A is 3 over 5, tan 2A will be 24 over 7. So question 2, we are going to solve this question using those formulas. So for question 2, I'm going to use 2 methods. One is the formulas I wrote. Then the second one is other parts of trigonometry that I have not actually done and is not really under 100 level trigonometry, it's O level trigonometry. So we want to look for cos 195 in short form. Once you hear short form, remember these angles: sine 30 degree, cos 30 degree, sine 60 degree, cos 60 degree, sine 45 degree, cos 45 degree, tan 30, tan 60, tan 45, sine 90. Those formulas, those values, you have to know them by heart. You have to know them by heart. So first of all, there is something called a special angle. Any angle that can be formed from these angles, let me add 90 degree to it. Any angle that can be formed from any of these angles is called a special angle. For example, 15 degree. I can get 15 degree from 45 minus 30, 60 minus 45. So 15 degrees is a special angle. Also, 45 plus 30 is 75, so it's a special angle. But how do I get 195? 90 plus 90 plus 15. That will also be a special angle. That will also be a special angle. So I'm going to break this down using 90s, multiples of 90s. So cos 195 is the same as cos 105 plus 90. Remember that we said when you have cos, something plus something is cos cos. If it's plus, you use minus, sine sine. So you have cos 105 cos 90 minus sine 105 sine 90. So remember that sine 90 is 1, cos 90 is 0. So this side is out. So you are left with minus sine 105. So it means that cos 195 is actually the same thing as sine 105. So let's also break this down. 105 is the same thing as 90 plus 15 degree. 90 plus 15 degree. We agree that. Or we can say this 90 is the same thing as 60 plus 30 plus 15. So we can add this together. We have 60 plus 45. So I can make 105 60 plus 45. So what will be sine 60 plus 45? Remember for sine we said it is sine cos then cos, sine, cos, the same. So we have sine 60 cos 45 plus sine, we used 60 before, we'll now use 45, sine 45 cos 60. But do not forget that there's a negative sign some here, so we have this negative here. What is sine 60? You have to know that by heart. Sine 60 degrees is root 3 over 2. So we have root 3 over 2 times cos 45 is actually root 2 over 2 plus sine 45 is also root 2 over 2 and cos 60 is 1 over 2. So when I do this, I will have this times this. That will be root 6. 2 times 2, we have root 6 over 4 plus root 2 over 4. Yeah, this is what we are going to get. So this is the same as minus root 6 minus plus root 2 all over 4. So let's check the options. There's none of the above in the options. So, but we have this in the options. So we have to find a way to make these options work with this. We have to find a way to make this look like the option, because it's obvious that the correct answer is there. So first of all, let's observe this option D. We have negative, this is it. So remember that there was root 3 times root 2. So what I'll do is, I will start from here again. If I bring out this root 2, I will have minus root 2 open bracket over 2. I brought out root 2 over 2. I will have root 3 over 2 plus 1 over 2. What I'm going to do now is I'm going to multiply by root 2 all over root 2. There's a reason why I'm doing that, so that this denominator will have 2 root 2, 2 root 2. So when I do that, what I will have as my final answer, root 2 times root 2 is 2. Root 2 times root 2 is 2. So that 2 will cancel out with this 2. We are left with minus 1, open bracket, root 3 plus 1 all over 2. But there's another root 2 here, so we have 2 root 2. So this becomes the correct answer. So what I did is, I brought out, this becomes the correct answer, because if I open this bracket, I will have minus 1 minus root 3 all over 2 root 2. So what I did was that I brought root 2 over 2 out. Since it's common, what will be left is root 3 over 2, 1 over 2. Then to remove this square root here, I put square root of 2 divided by square root of 2. This is the same thing as 1, so I did not alter the question. Here, root 2 times root 2 is 2. 2 divided by 2 is 1, so there's 1 here. We are left with root 2 here. Ordinarily, this is root 3 plus 1 all over 2. But there's a square root here, that's why it's root 2. So our answer is option D. Now let's move over to question 3. So for question 3, we ask, find the values of y between 0 degree and 360 degree such that for all values of x, if this is this, so the condition is sine x plus y plus sine x minus y is equals to sine x. So we are looking for the values of y, not x, such that for all values of x, this is this. So I think they are trying to make x to be a constant value. So we are seeing x as though is a constant value here. So first of all, remember the sine formula. So this is sine x cos y, don't forget. Then plus, because there's plus here, sine y cos x. So we have been able to use this formula. Then plus this guy, let's use the formula for this guy. We have sine x cos y minus sine y cos x. Everything equals to sine x. The board is not long. This is one straight equation. So these and these are the same. They can cancel out. We are left with this. So if I add this guy, we have 1 sine x cos y plus another sine x cos y. Together we have 2 sine x cos y. Everything equals to sine x. Everything equal to sine x. Now you can see that we can divide. We can actually look for sine x here. We can actually look for sine x here. So how do I look for sine x? I can divide both sides by this. I will have 2 cos y equals 0, equals 1 rather. So if I take divide both side by 2, I'll have over 2. Now, what angle is the cos of that angle 1 over 2? 60 degrees. So y is 60 degrees because cos 60 degree is 1 over 2. I think there's another angle that makes this true, but I think we'll choose only one value. So remember the quadrant acts at this 1 over 2 is positive. At this angle cos is positive, and if this is the angle, here will be 360 minus theta. So 360 minus 60 degrees, 300. So y is 60 degree or 300 degree. Now, like I earlier said, I said you can actually look for x. They can ask you for sine x or x. Now, from here, what if I was asked to look for x, not y? Now, this is the same thing as so I can bring sine x and make it common. What will be left is 2 cos y minus 1 equals 0. Now, in mathematics, when two things multiply to give you 0, it means either one of them is 0 or both of them is 0. So it means that sine x is 0 or 2 cos y minus 1 is 0. So using this, we have gotten the answer 60 degree or 300 degree. Using this, x is equals to 0 degree or 180 degree. But then we were not asked to look for the value of x. So that will be all for these 3 questions.